welcome. Just gonna set up real quick with some tunes in the background. Oh, another day, another math. One of the things I love to go through. I love math. Let's just call it what it is. Math, when understood, when looked at as a puzzle to solve, is different than when looked at as a task to complete by a teacher. And when we take a look at how we are taught math, it's not good. Not good. It's not the way it should be taught. The way we look at math is a burden, which is unfortunate because when you really take a look at the perspective that math gives us, and even me just saying the word math, I know some of you are just like, uh, uh. Every time I say the word, they get stabbed in the heart just because of the word itself. But that's the stigma. That's the stigma that we're all built up with because people suck at teaching and they ruin it all for the rest of us. Right? Is that not fine? Yeah, let's put some little. Yeah, alright. So, I don't want to make it too loud now. So, I beg you, as a scholar, and for you as a scholar student, do not let stigma ruin and take away a powerful tool from your arsenal. Don't. Don't. This is what they would love. They. The ones that stopped teaching finances in school, the ones that stopped giving everyone the education necessary to understand the world around them. They would love nothing more than a hollow vessel that walks around and just follows instructions. That's it. But when you know and you see and you calculate, follow the money. That's all it comes down to. Anyway, I digress. That's money related talk, which we can do in the future, but not right now. So, the deepness of the subject. I digress to try and stay on subject, but I tangent to go into deeper thoughts that my philosophical brain's like, oh, man, the world's crazy. The world's crazy, y'all. They really did a number on humanity. They really did a number on humanity. Also, I need to fix this mic a bit. I can hear everything. Everything. Except my whisper? That's weird. Maybe because it's... ADHD brain, hold on. Can I maybe soften this so it doesn't make that? Nope. That's better. Wow! The desk was vibrating into my microphone. I had to put a pad on bottom so it stopped taking in every single noise of me moving around and stuff. It's still doing it though, but whatever. So yeah, man. I wanted to go over some and kind of build up on it because I've done a couple of ways to get started on building up a type of understanding that's far disconnected from the way we learn it in school. A lot more realistic, a lot more applicable. And since we learn English as a first language, why not compare it to something like a language, right? This is why I'm trying to kind of put all the pieces together into a linguistic type of format, which isn't too far gone. And a game too, a game rule, the players, values, variables, operators, procedures, map board, box grid, white space, movement of said players. And yeah, feel free to chill with me while I kind of get myself orientated here. That's a good place to start, honestly. Biggest confusion is when we're doing the math, right? We're going through those classes. It's fifth grade, it's sixth grade. We're seeing these symbols start to change and things start to adjust, right? I wouldn't call it here. Numbers are values, a description of how much something is, how many there are, etc., right? Variables, what I like to see them as, are boxes containing something. We don't know what it is. Many times, if it's just X and find X, that's kind of the idea. We want to open up the box and see what's inside, but we have to do it strategically, piece by piece, moving stuff away from the box, clear it out. You know, you've got some other boxes on top. You want to move them off and eventually get the box by itself in its solo glory and then open it up to see what number is inside. The X that we refer to in so many cases as a variable, it's just a label. It can be X, it can be Y, it can be P, it can be Z, it can be whatever you want it to be. Whoa, that was cool. But in the end, it's just a label. When we use that label, we're essentially just saying, hey, this thing in this location, and location-based understanding is much more important than remembering the labels that we see. We'll get to that in a little bit when we're dealing with like formulas, linear equations, and all that kind of stuff, especially areas and all that, area of a square, triangle, etc. So when we're dealing with labels, all we got to think about is what's around the label, what's around my box, and how do I proceed to move the things that are in the way. If there is a number on top of my box or something on top of my box, how do I move it out? And it normally proceeds with the opposites of the interaction. What are my box and this thing in the way doing with each other? Are they multiplying? Then we divide. Are they adding? Then we subtract. And it's always a case of the opposites to get rid of said impeding objects to isolate the box X. That's it. Every single time. Forever and ever. We just look for a way to get this label by itself. And then we get the understanding of X equals 58 or whatever X would be in that problem. The biggest misconception is to kind of try and anchor or give that X a value and forever keep it as if it's saved in our brain. That's what we try to do. We try to always memorize, always try to say, oh, X is at 58. Okay, is that forever? Then you go to the next problem, and then X is 2. And then you're like, wait a second, I thought X was 58. A lot of confusion comes in the dynamics of the change, the variable nature of the change. A variable in general sense is just something that changes. That's it. And it's variable based on different problems. So once we decouple ourselves from the fact or the idea that we have to have a single value for X, then we understand it's just a box. It's got stuff in it, and we're just trying to build it out or dig it out of its pile of junk and get it by itself to see what's inside. That's literally the hunt for all algebra right there. Just hunting for variables, digging up boxes, trying to figure out what's inside, and then putting context to what we found. What was the number involved with? What was the unit measure? What was the meaning of that number? But here's where the confusion starts to come in early. And I've seen this happen from 5th, 6th, 7th grade, always within that branch, maybe 4th as well, where we start to adjust the way we do multiplication. I wouldn't say do, but see. We see it differently, or they're giving it to us in a different way, and it confuses us because it's not an X anymore, right? The little X that shows multiplication. Now it's a dot or it's parentheses. That idea is just because of convenience over time. As we teach students more and more pieces of mathematics and algebra, the more symbols start to conflict. They start to look the same. They start to cause confusion. And we end up trying to organize these ideas in a more fluid manner. Meaning, if we have a bunch of different numbers with dots, we wouldn't use, let's say, the dot multiplier. We would use parentheses. So if you had a lot of decimals, it confuses us to see this extra dot in the place. So the confusing part of 4, 5, 6, 7, 8th grade within that bound, and I've seen some students carry this on all the way to like high school, middle school. They use multiplication, but then all of a sudden the multiplication they're used to was this, the x, and all of a sudden it changed to a dot, and they're like, wait, what is that? Why do we have dots? And then all of a sudden we have nothing. That's the worst. That's continuously the worst part of a lot of people's experience. What do I do when I have nothing between two numbers? Oh, between two numbers, like let's say 22. Well, that's 22. We can kind of give it that number duality, tens and ones. But if we have like 2a, that breaks everything apart. Students are like, what do I do with 2 and 8? There's nothing in between. How do I do math with that? Well, that's the case for where we put an invisible parenthesis that separates the two from each other, giving us 2 times a. And that's where this sort of end result of what multiplication looks like over time tends to adjust to. And that's the problem. We don't explicitly say, hey, get ready, you're about to see math change in front of your eyes. They're just like, oh, yeah, the x that we use for multiplication, well, now it's a dot. And then later it's like, oh, well, the dot that we use for multiplication, now it's never going to be shown again. Just make sure you remember it's there. That's literally the instructions for most of these classes. So that's one of the pieces, is to remember what happens when our symbols change. Velo delayed. Velo. Hello, Velo. What that mean? I can probably put up a chat if anyone's chilling. Let's see. Where we at? Where we at? There we are. Oh. Hey, if we're down for Python, we're down for Python. I was going through a little bit of logical understanding, because Python, in the end, is going to be very much within the bounds of, if we go into engineering, we need to have a little bit logical foundation, right? So I'm kind of doing a little math today, but if you're down to learn with, yeah. I might cut the stream in about 30 and then swap to Python. I like to be democratic. If I get a lot of requests for something, I will adjust, but it probably will be with a stream cut, so I can kind of organize the videos in different sections. So math in one stream video, and then Python in the other. But what do you like about Python? What are you looking to learn about Python as I'm going forward? Hey, fair enough. Good luck on the tire replacement. Be careful. Hope your God, what's that thing called? Jack? Yeah, the jack is doing good. So the biggest issue we have, again, with the, and I'm always going to refer to just the typical school system, because I have so many bones to pick with the educational system that I can probably go all day about being an old man grumping around about how literally teachers are not given the freedoms, the comfort of existence to be able to really apply what they want their class to be, right? It takes, I mean, consider this, even as a tutor, there's not a case where I have one student that I don't still work on the outside of our session hours. I have to prepare, I have to organize their papers, I have to see where they are and prepare for the next sessions. All these kind of things that is just work outside of the 1 hour that I have with a student. But that's not included in the actual costs, right? That's kind of like extra work. So imagine a teacher having to be given paperwork to grade, and then they're getting paid nothing. So they're just not being treated as good as they should. But that's my rant on that. And in that sense, the school system doesn't really apply a good sense of information when we're learning this. So again, the biggest changes we see, for instance, is a times x, as far as the symbol multiplier, changes, not an x, maybe it's a little bit of a big X here, but bam, bam. It changes to a dot. It's still multiplying. It's still multiplying two things. But then eventually it disappears into nothingness. So I always ask my students, what happens between two things when there's nothing in the middle? and it's always caught them off guard. What could they do? What happens? There's nothing there. It's always going to be multiplication. So the same thing happens, and we can see the example here underneath with 5 times 2, 5 times 2, and 5 parentheses 2, or times. And this does make the biggest difference between us having the number 22, or if we put a parenthesis around 2 and having the operation of 2 times 2. So the parenthesis becomes the main focus of multiplication. Same thing happens with division. From the division sign to the slice that you would have when you're doing calculator work, the forward slash, to the actual fraction. We fail to always recognize fractions are just divisions in disguise. That's all they are. When we do divide, we can put them in fraction form and do a bunch of other algorithms to it. But in the end, it's still division. I'm also kind of building up a little bit of the, let's see, the math board. Ah, yes. The big instinct of the matter. In programming, just like in any math or anything we do, there's implied ideas we have to always think about when we're not actually writing them on code or on paper. In math, for instance, 7 plus 5 is straightforward. We see the plus, we say we add these, and then we do the adding. But we fail to recognize that this is actually a positive 7 and a positive 5 trying to combine. It's a different perspective overall. It does the same thing. The product, the end result is still the same. But we fail to recognize that signs attach to the right. So this would be a negative 2. And this would be a positive 5. There is this concept of what happens between different signs. Well, if the signs are the same between two numbers, they add. Plus and plus, plus. They add. Positive 7 and a positive 5, positive 12. But what if we flip it around? What if we have negative 7 and a negative 5? Lo and behold, they still add. They just get to be a negative version of that same number. So same signs will always add. And then the real trip here is that we think of subtraction as having a minus sign between two numbers. That's incorrect. Believe it or not. It's not about the minus sign. It's always about what's happening in the environment around. That's a 5 minus 2. However, it's actually a positive 5 trying to mix with a negative 2. Subtraction is not the fact that there is a minus sign visible to us, because then that confuses us on the minus sign and the double negative above flies. Subtraction is mixing two different signs together. That's what it really means. And that's the piece that I have to reteach all my students to understand how to keep track of the sign. The problem is, for me too, the negative is always going to be the worst part. Just negatives moving around, multiplying, adding, subtracting, just going all over the place. And with my ADHD sometimes and my dyslexia on top of things, it can get messy and I can forget certain things about where was that negative? Where did that come from? But when we adjust the way we think about positives and negatives, or addition and subtraction, and think of them as these numbers that hold a sign, and then when two of same sign types combine, they add together regardless of the sign. It can be two negatives or two positives. They are, however, the same. There's two of them. The only time we ever apply subtraction is when we do opposite signs. A negative 2 and a positive 5, or a positive 2 and a negative positive 5 and a negative 2. That's the definition of subtraction, is combining different types of numbers or signs, different type of signs in the numbers. And this would be very, at first it's had students a little confused, but even 5th and 6th graders, when they start to apply this, they stop making mistakes with negatives. They always think of the sign. Plus and minus, subtract. Minus and minus, add. Plus and plus, add. And they just follow those strict little details. So that's one of the ideas I like to think. And the next step is thinking about how functions, how applications, how mathematical formulas have white space. We use white space in the form of breathing room, kind of giving a space to either organize our code, or in some cases using it strategically to comment and put space in between. Well, in mathematics, we're thinking of a similar factor. A sentence has space, just a typical sentence we would use in English. If we were to compare spaces and how spaces work in a language to how math uses quote unquote spaces, we would associate spaces with addition and subtraction. Those are the spaces. So they kind of act as the buffer space between terms. So if English gave us words, and if words made sentences, the same defined piece in math is a term for the word and a expression for the sentence. That's how we bring it all back down. We're looking at a sentence and a word, or a word in the sentence, as a term in an expression. So when you look at the A sentence has space, and if I asked you how many words are in there, you would say technically 4. A is not a technical word, but it counts. And if I asked you how many terms are in the equation underneath it, using that space as guidance, as the white space, that's why white space is very important in programming, then you would say, well, there's 4 terms because there are pluses and minuses separating them. And this is how I like to relate math to English, because we know English, we use English, we don't think about it, and there's some things about English that essentially still flabbergast us, or we just do it because we've done it for so long and we can't explain. And this is coming from myself as well. I teach mathematics on a regular, but you give me a student in English and I'd be like, I can try and help, but sometimes I just speak words without thinking about it, and it just happens, just a manifestation of words. But then I go into more details and I start thinking about with the student how I'm speaking, what the words are. Then there's like root words that I'm thinking about. Like, how did I know what that word meant when I didn't actually ever really learn it? And they're like, I use this other word over here to connect this word because of the words in between, or there's a root word that I kind of know, and then there's always a connection there. And that's essentially what we do in mathematics. We make connections with the surrounding pieces. So in the detailed fine print of how many terms would a expression have, all we do is we seek the positives and negatives. The only case here that's a little bit different is that there is a parenthesis that kind of gives a higher priority of hierarchy. The parenthesis combines the 3 and the 2, or sure, we can call it 5. But in the end, there's kind of like a term set on the inside. So while on the outside we can think, all right, we have one sentence, or 1 word, 2 word, 3 words, and 4 words or terms, there's kind of like an internal set of words, terms, 3 and 2. It's like a 2 terms inside of the parenthesis versus 4 terms on the outside of the overall perspective. This is also another key to math. We like to look at all of this and be like, wow, where do I begin? You just start 2 at a time. Always 2 actions at a time. We're using PEMDAS. We essentially taken apart the pieces and try to organize which 2 we'd prefer to do. Sometimes we just do it from left to right for comfort. Sometimes we notice, hey, parentheses can go first. We'll add the 3 and the 2 together. Whatever kind of steps you take is valid as long as you follow PEMDAS. So the process in that doesn't necessarily get in the way, but rather it complements, I can do multiple things. Like I can take 7 times 5. It'd be 35. And I can put the plus there. And I can do 8 divided by 4. That's 8 divided by 2. That's 4. Sometimes I think too quick and I get the answer in the problem. 8 divided by 2 is 4. Then I put a plus there. And then I can do the 5 here, and then the 3 times 5, 15. So there's steps we can always take, but in the end, I've maintained each of these terms still separate until the very end. So it doesn't matter what order you go in certain cases, but we want to still prioritize PEMDAS as far as kind of the guide. And that brings us to a language when it comes to speaking or doing math, right? There is PEMDAS, and then there's where is that? Where is that? Game rules. I need to organize myself better. Try to take notes from every student I've had and kind of put them into an organized mess and stuff. But let me see. Cool. Life insurance. Can I please? I don't know why it's doing this. Okay. My tablet seems to be having a little bit of a technical difficulty figuring out what the heck it wants to do. So while it's loading, I need to find that little bit of detail. Okay. Can we just pick one place and just stay there, Mr. Tablet? Are you in the way? Is something lagging you down? Oh my god. Yeah, I'm gonna close this. You're constantly flipping all over the place. There. Alright, reset. Aha. Yeah, okay. There's some also like some other things I wanted to go over, but they're more like practice. Don't want to do anything crazy practice. I still want to keep it conceptual and language based. Something went wrong. Great. Try again. Come on now. Do I have to restart my tablet? Probably will. Alright, small mental break and tablet break. But I'm gonna set this up real quick with some more. Well, that ain't good. For some reason now my OneNote's just decided to take a crap even with a restart. Which I need. That's super weird. I swear Microsoft is like destroying all of its old products just so it can make people go to Windows 11 and blah blah blah. Alright, well, there that goes. Well, I guess I'll switch to programming now. Let me adjust a little bit here.